Hello. So we will be going over numbers 41 through 60. This may be done in more than one video, but 41 through 60 is what we will be doing. So we will start with number 41. Jill had a list of 14 test scores for which she had calculated the mean. All right, so right there's a key word that you need to remember, and that's mean. Mean is found when you have a set of values, you add them all up and divide by the total number that you have. Okay, so she then realized that she had forgotten to add in the bonus, which everyone got correct, so she added 5 points to all grades. What happened to the mean? All right, so if everybody's test score increased by 5 points, we want to know what happened to the mean. So if you are unsure and you're like, oh man, I don't even know, you could always do this. So let's say we had two students who took a test, all right? So we're going to say that let's say they made a 90 and the other one made a 93, okay? So if I had two scores of 90 and 93 and I want to know the average of that, I would do 90 plus 93 and I would divide it by 2. I get 183 and I divide that by 2 and I get 91.5. Okay, so the average there is 91.5. What she's saying is she forgot to add in 5 points for the bonus. So that 90 would have been a 95. That 93 would have been a 98 because we added 5 to each of those. And we do the same thing. Okay, so 95 plus 98. And you could use any numbers. I just picked those two. 95 plus 98 is 193. Divide it by 2, and you get 96.5. So when I added 5 to those test grades, what happened to the mean? What did it also do? It also added 5 to the overall average, right? So what happened is the mean rose 5 points. 30 elementary school students are surveyed and asked to name their favorite color in reporting the results, which is the best measure of central tendency. So if we're trying to figure out what is the favorite color in the classroom, so I'm looking for the range, the mode, the mean, or the median. Well, this is categories, right? So color is a category. So I would want to use the mode. So which color is chosen the most? The height of a plant in centimeters is recorded each day for 10 days. The function y equals 1.73x plus 1.87 is determined to be a good fit for the data. On day 6, the recorded height was 12.5. How close is the predicted height to the actual height of the plant? So this is a residual problem, and we don't do residual anymore. So really, we could skip number 43, but we could skip it, or we could try to figure it out if you wanted to. So, it's day 6. So if I were to plug in a 6 here, okay, if I let x equal 6, and I plugged it in, I would get y equals 1.73 times 6 plus 1.87. So if you did that, 1.73 times 6 plus 1.87, what you get is 12.25, okay? So this line of best fit gives you a predicted value, okay? So if I were to predict how tall this plant was going to be, I would predict that it was going to be 12.25 centimeters tall. The recorded height, that's the actual height right there. So the actual height was 12.5. So how close were we? So from 12.5 to 12.25, the difference would be 0.25 there. So the equation tells you predicted. Okay, so that's how you would use that, just in case you see it, but you shouldn't. Number 44, the SAT scores of 4 groups of 10 students are shown below or over to the right. Which group has the smallest range? Remember, range is max minus min, okay? So really what you just need to do is figure out the maximum and the minimum for each group, okay? So in group 1, we start looking. You look for the maximum. I'm looking. Looks like 1700 is going to be my largest score here. So then I look for my smallest score. I'm not sure why that eraser is staying on my pointer there. Looks like the smallest score here is 1300. So max minus min, 1700 minus 1300. That gives you 400 for your range. So then I do the same thing. I don't know why. I'm trying to change it. It didn't work. I'm going to do the same thing. I look for the maximum on group 2. I see 2100. And then I look for the minimum. Looks like maybe 1250. Is there anything less than that? Nope. So 2100 minus 1250. Okay, so 2100 minus 1250, you get 850 for the range. I'm looking for the smallest range. Right now, group 2 is out. All right, so now I go to group 3. I look for the maximum, 2000. Look for the minimum. Is there anything less than 1390? Don't think so. 1390. So 2000 minus 1390, and that gives you, ooh, I messed up, 610. I come back, I do the fourth one, 2150. That looks like the maximum. And let's see, minimum. Okay, 1400. Is there anything less than 14? Oh, there's 1340. There you go. So 2150 minus 1340. And I get 810. So the group that had the smallest range was 400. So that would be group number 1. Okay? All right, so number 45. Gabriel interviewed his 30 classmates on whether or not they own a bike and live near a pool. He displayed his results in the 2A table below. Which statement is true? Okay, so I, first of all, notice there's no totals here. So I'm going to just give myself some totals because I just like to have them. So if I added total, 8 plus 7 is 15. 10 plus 5 is 15. If I did the same thing here, that's 18, that's 12, and what they should give me is a grand total of 30. Okay? So I want to know which is true. So the first one says over 50% of bike owners live near a pool. Okay? Well, how many people own bikes? Okay, the total that owns the bikes are 15. Of those 15, how many live near a pool? 8. All right, so for A, I'm going to extend this page. So A, if I do my work, 8 out of 15 is what I'm looking at. Okay? All right, so 8 out of 15. What is 8 divided by 15 times 100? Because we're changing it to a percent. 8 out of 15 times 100. That would give you 53.3%. Is that greater than 50? Yes, that's true. All right, so A works, but let's just check the others. B says less than 55% of his classmates live near a pool. So of all the classmates, less than 55% live near a pool. So he had 30 classmates, 18 live near a pool. So that would be 18 of the 30 times 100. Okay, let's see what that percent is. 18 divided by 30 times 100. That's 60%. Is that less than 55? Nope, that's out. All right, so C, it says 50% of his classmates own a bike and live near a pool. of classmates own a bike and live near a pool? Well, there were 30 classmates. Out of those 30, how many owned a bike and lived near a pool? 8. So 8 out of 30 times 100 is what we're looking at. 8 divided by 30 times 100. That's 26.7%. Is that 50%? Nope. All right, and then D says 67% of his classmates that live near a pool. So classmates that live near a pool do not own a bike. So of the ones that live near a pool, so live near a pool total is 18. Of the live near a pool total, how many don't own a bike? That's 10. 10 out of 18, and then you multiply by 100 to change to a percent. 10 divided by 18 times 100, you get 55.6%, which is not 67. So A was the one that worked here. Okay, 46. The table shows the number of boys and girls that have black, blonde, brown, or red hair color. What is the probability just means percent, that a randomly chosen student is a girl with blonde hair? Okay, girl with blonde hair, that would be 6 possible students that fit that criteria. Well, but I don't know. It says a randomly chosen student is a girl. So here's your total. So I need to figure out the grand total. So 4 plus 5 is 9. 4 plus 6 is 10. 10 plus 8 is 18. 2 plus 1 is 3. And then if I added all those up, you get 9 plus 10 plus 18 plus 3. I get a total of 40. That should be my grand total right there. Okay. So what I'm looking at is 6 out of 40. 6 girls out of 46. So out of 40 total students, 6 are girls with blonde hair. So I multiply it times 100. So 6 out of 40 times 100. 6 divided by 40 times 100 equals 15%, which is A. All right, number 47. George asked 5 of his friends how long they studied for the last math test and what grade they received. He found a linear regression equation for the data to be y equals 9.6x plus 65.8. What does the 9.6 mean in the context of the problem? All right, so it's how long they studied and the grade they made on their math test. So x is what's changing. All right, so the time is what determines the grade, right? So x is what you're changing. So as your hours increase by 1, so I'm just going to start writing this out as interpreting the slope. As hours increase by 1, the test score, all right, this is where the slope comes in, is 9.6. Is it positive or negative? It's positive. Test scores increase by 9.6 points. Okay, so I'm going to figure that out. So let's see. A says friends on average study 9.6 hours. If they studied 9.6 hours, they would get a 0 on the test. They should study 9.6 hours in order to get an A on the test. For every hour they study, their grade goes up 9.6 points. That's D. Y'all, that's the slope. It's the rate of change. So you want to select, you want to pick the scenario that's representing the rate of change in the slope. So if you were this 65.8, that's the y-intercept. And what that means is if they studied for 0 hours, they could expect a 65.8 on the test. 9.6 is how the grade's going to change. 48. Olivia is growing roses and keeps track of how much fertilizer she adds to the soil and how many blooms each rose has. All right, I'm going to have to pause right here. I'm using a different video recorder, and I'm about to run out of time on this one. So we'll pause right here, and then there will be another video starting at 48.